Hi friends, today I am going to cover the feature selection with the correlation method. So in previous class I already discussed about the basic statistical filter methods. Those are the variance threshold and remove the duplicates. So this is the topics I covered in my previous lecture. So in today's topic I am going to explain the correlation based method, and next video I am going to explain the rest of the methods. So what is the table of the content correlation method for the feature selection? So here, remove the features. Remove the features which are highly correlated, which means that, for example, this is my data. So here data x1, x2, x3 and y. So this is my data frame. So in this data there are the three independent variables and y is my target variable. So here feature x1 is correlated with the x2 and feature x1 is correlated with x3, and these features are correlated with the target variable. So we have to remove the features which are highly correlated. So if the independent features are highly correlated with the dependent features, so then need not to remove those kind of correlated features. For example, in this table, this x1 feature is correlated with this y, means target variable, or x3 is correlated with the target variable. So at that time, these kind of features we need not to be removed. Even there is a correlation existed with between the independent variables and the target variable. For example, x1, x2, x3 and y. If independent features are highly correlated among the independent variables, so among the independent variables, so which means there is a correlation between the x1 and x2 and x1 to x3 and x2 to x3. So among the independent variables are highly correlated greater than 80% or the 90% or the 70%. So we have to drop those kind of features and we have to train the remaining features, which means that, for example, there is a correlation between x1 and x2, there is a correlation between greater than 80. So we have to drop either x1 or x2. So if you suppose to drop the x1 and consider the x2 feature and take the other variable x3 and use this independent variables, you have to train the model, which means that among the independent variables, if there is a correlation greater than 80% or 90%, so we have to drop any one of the correlated features. So remaining features are considered for training the model. So this is the way we can remove the features. So how to identify the correlation features? So with the help of the correlation matrix, we are supposed to choose the features. So now going to the practical section. Here I am importing the dataset. So my dataset is the mobile dataset. So in this mobile dataset, if you see, so this is the data. So in this data, there are the 21 columns are existed. So among the 21 features, and the shape will be the 2000 observations and 21 columns. So in this data, this is my target variable, means price rise. So first of what I supposed to do, divide my data into the independent variables and dependent variable. So after the dividing the data from the independent variables, so first we have to identify the so for removing the correlated features, first we are supposed to split the data into the train and test split method. We can divide the data into 80%, 30, 70% for training, 30% for the testing. So this is my x train shape and this is my x test shape. So here I am going to apply the Pearson correlation. So Pearson correlation, so we have to check the correlation on the trained data. If existed the correlation among the independent variables, so those features may drop from the x train and x test. So if I execute this cell, so here I am going to apply the x train, I am going to apply the correlation matrix on the x train, but we can't apply the correlation function on the x test. So if you observe here, there is a correlation. So there is a correlation between this 3G and 4G is 0.58. See, there is a correlation between PC and FC is 0.64. So this is the correlation between the PC width and the PC length. So which means that here we are supposed to apply the threshold value. So here select the highly correlated features. So how can you select? So the correlation function will remove the first correlated features that the correlated with the other features, which means that when you supposed to apply this correlation function, so here I am passing the correlation function. So this is my x train. Under this x train I am supposed to choose the threshold value is 0.6. If I choose the threshold value is 0.6, so I used correlated features are the only one. So what is the correlation features? So there is a PC. If you see here, so this is the correlated feature. So 0.64, which means this is PC, and this PC is correlated with this TC. So this PC and TC FC, so these two features are highly correlated, greater than 60%. That's why we are supposed to drop any one. So that's why here you drop the one feature. We drop the one feature. So this is the correlated feature. So what is my x train? Initially my data will be 1400 observations, 20 columns. So after drop the, so here I will check the another threshold value. Here 0.6, I am going to change 0.5. If you take the 0.5, so these are the number of correlated features are existed. You can check it. There is a correlation PC. If you see here, so 0.58, which means that greater than 50%, there are the 4 features are existed. So what are the 4 features? The 4 features are the PC, so PC, fixed width, 3G and SCW. So these are the 4 features greater than 50%. So if you observe here, so there is a correlation 0.64, 0.58, 0.64, 0.58, which means that the PC is correlated with this FC, and here 3G is correlated with the 4G, and there is a FC is correlated with PC, and here 4G is correlated with another feature. So these are the 4 features. These are 1, 2, 3, 4. So there are the 4 correlated features existed. So among the 4 correlated features, we have to drop the first correlated feature. So we have to identify these 4 correlated features. So what is the so I have to drop the correlated features from the my X train. So my data shape will be 16. So initially I have the 20 columns. When I apply the correlation and drop the correlation features, we got the remaining features at the 16. Similarly, I have to drop the correlated features from the my test data. So this is my X test shape, this is my X train shape, which means this is the features from the free from the correlated features. So what I am doing right now, so build the one of the model, that is the RFC model at threshold 0.5. so here I am choosing the threshold 0.5. so build the RFC model. So what is my size? Initially my data will be 20 features. So I am going to build the RFC model. So at that time the time will be 30 milliseconds. So my accuracy and the 20 independent variables is 87.5. This is my confusion matrix. So from the confusion matrix we can observe here. So what is my correct predictions? So 147, 111, 117, 150. If you add these 4 diagonal elements, you will get the 575. So what is incorrect predictions? 4 plus 15 plus 22 plus 12 and 13, you get is 75. So accuracy is 87.5%. So this is my classification or report. So now I am going to build the same RFC model on the 16 independent features. Why? Because I have to drop the correlated 4 features. So remaining features are the non-correlated features. So I have to train the model on the non-correlated data. So this is my non-correlated features. So I have to train the model. So you can observe here they are the 20 this is milliseconds, and if you observe here this is the milliseconds. So means the difference is there. This is my X test and this is my accuracy. So on the 16 independent variables my accuracy will be 86.5. so little bit decreased, but anyhow time is also be decreased. So my correct predictions are the 519. So before my correct predictions are 525, here 519. So this is the way we are supposed to develop the RFC model on the correlated features. Suppose I am going to take the correlated features is my 0.6. So 0.6, let's see, only one feature is existed. So now my data will be 19 features. Now it is 86.67. so which means that we have to train the model on 19 independent variables. So this is the way we can supposed to develop the model on the correlated features. And I am going to explain the one more example of the continuation class of the previous lecture. So in previous lecture I already taken the same data set. So up to previous lecture I cleared these topics: constant features, quasi-constant features, duplicate features. So in today class I am going to cover the continuation of this the data set. So initially these 3 kind of features are identified: constant features are identified, quasi-constant features are identified, and duplicate features are identified. And those 3 kinds of features we dropped, and remaining features are feed to the correlation coefficient, which means that, let me check it, let me execute it. So importing the data, so this is my data. So initially 371 columns are there, so I am not going to explain here, already I was explained in my previous lecture. So if you watch and go and see the lecture. So here I am not going to explain these topics, I will cover. So I will continue the from previous lecture. So in previous class I covered till up to here. So means we have to identify the shape of the trained data after drop the duplicates. So after drop the duplicates, my data shape will be 60,816 observations and 255 columns. So now this data so this is my at present my data shape will be xtrain non-quasi and xtest non-quasi dot shape. So which means these 255 features are the free from the this is the features 255 features from the these features does not contain no constant, no quasi-constant, no duplicate. So these three things are dropped. So from this data what I am going to do, so I take in this data, I am going to check the correlation matrix. So here I am going to take my data a threshold value 0.8. If I choose the threshold value 0.8 on my xtrain, so this is the data I'm feed to the correlation here. So I got the 133. So means that, so what is the correlation features? So these are the correlation features, which means that initially my data will be 255. Actually original my data will be my data will be 369. From the 369 we are identify the 34 constant features. So drop the constant features, so 34, and remaining features are the 335. So from the 335 we have to identify the 63 quasi constant features. So we have to drop the 63 features from the 335. So we got the 272 features. From the 272 features we have to identify the 17 duplicate features. So we have to drop this 17 duplicate features from the 217. So we got the 255. So now this is the 255 features. So among the 255 features, if I take the threshold value is 0.8, which means 80%. So there is a correlation among the features independent variables greater than 80% at the 133. So which means I have to drop the 133 features from the 255 features. So remaining features are the 122. So these 120 features are no constant, no quasi-constant features, there is no duplicate features, there is no correlation features. So these 120 features are free from the constant, quasi-constant, duplicates and correlations. So those 120 features are, we train the model with these 120 features. So in place of 0.8, if I suppose to take 0.5, so we can see how many correlated features are existed. (191) features are existed. If is 0.9, how many correlated features are existed? 104. So generally people, so here the threshold value is selected by the domain experts. So here domain knowledge people can able to tell we have to choose the threshold value. So threshold value decided by the domain expert people. So now what I am doing, so I have to drop the correlated features from my 255 features. So from this xtrain non-quasi means 255 columns, I have to drop this 133 features. So I got the remaining. So this is my data set. So this is the remaining data set. So means, so here we are not going to change any number of observations, only features are going to change. So which means when I choose the threshold value 0.5, when I choose the threshold value 0.5, so this is the number of correlated features: 0.6 179, 0.7 157, 0.8 133, 0.9 104. So how can you choose the threshold value? So if based on the threshold value, the features are going to change. So this threshold value decided by the domain expert. So here what I'm doing, so I'm going to check the evaluation performance like in previous class. So initially my original shape will be 369. So after drop the 34 constant features from the original feature 369, so remaining features are 335. So this 335 has the free from the constant features, which means this 335 does not contain the constant. So from the 335 we have to drop the 63 quasi-constant features. So 335 minus 63, this is the 272 features. So these 272 features, we have to check the duplicates. 17 duplicates are existed, then we have to drop the 17 duplicates from the 272, so we got the 255. From the 255 there is a 133 correlation matrix at threshold value 0.8. so at present remaining features are the 122. Initially 369 and 34 constant features are dropped after the 335. So from 335 63 quasi constant features are dropped. So now 272. From 272 17 duplicates are existed, so drop the 17, remaining 255. From the 255 133 correlated features are existed at threshold value 0.5. so this is at present. So now this data I'm going to train my model. So here what I'm doing, so I'm going to apply the model in every, so I'm going to apply the model on 369, 335, 272, 255, 122. So here number of features 369, which means here the dimensionality is high. Here dimension is reduced compared to 369. So when it is going to increasing, which means that 369, 335, 270, so features are going to decreasing. So automatically time means execution time will be going to be less, and less resources should be needed. So I'm going to train my model on the 369 features. So for going to build the RFC, random forest classifier, on this my original features 369. So let's say how much time it is taken for executing the RFC on 369 features. So which means 15 seconds are taken. So now I'm going to check the result. So 95.33. So 95.33%. So correct predictions are and wrong predictions, and this is my classification report. So now I'm going to train the same RFC model on the 335 features, which means non-constant features. So I'm going to train the model on these 335 features, and my accuracy will be if you see, train the RFC model on 335 features, time is 15 seconds, 0.9 milliseconds. Here 15 seconds 26 2,61,891 milliseconds, and the time will be reduced, and accuracy will be 95.33 on the 335 features, and 95.40 is train the model on 272 features. 272 features. Here accuracy will be 95.33. Here accuracy will be 95.40, and here accuracy will be 95.30 at 255 features, and accuracy 90.46 at 122 features. So when the features are decreasing, So accuracy is about to same, but time is also be decreasing. So when you take in this, if you observe here, if you train the model on 369 independent variables, you got this much of accuracy. For executing on this train the model on 369 features, so this is the time was taken. If you observe here 95, 95, 95, 95, 95, so accuracy is about to same, but features are be reduced, which means there is a dimensionality reduction. So dimension initially 369, now it is 120, which means the dimension reduce the dimension. So for 120 feature, how much time it taken? 33 seconds. For 369, 54 seconds, which means that there is a curse of dimensionality, which means the dimensionality reduction can be done with the help of the PCA and feature selection techniques. So PCA was already covered. So here I am going to apply the feature selection techniques. We have to reduce the dimension from 369 columns to 122 features. So this is the way we are supposed to apply the correlation coefficient for selecting the optimal features. I hope you understand this concept. Thank you.